Hello. They have dimmed the lights. We've got some nice mood lighting going on, which is my sign that it's time to get started. Hello everyone, thank you for coming. I'm Ben Armstrong, Program Manager on the Hyper-V team, and I'm here today to talk about what's new in Hyper-V in the 2012 R2 release. Before I get started, a quick show of hands. How many people here have any version of Hyper-V deployed in their organization? Fantastic. That's what I like to see. Now for the fun thing. How many people are already on 2012? That is great. I wasn't expecting that many people. So how many people are still on 2008 R2? Okay, first showing of hands. So a couple of key things before I get started talking about all the new stuff in 2012 R2. I have a session later this week upgrading your private cloud. I strongly recommend that you all come to that. We're going to be stepping through the process for how to move from a 2012 deployment to a 2012 R2 deployment, or even from a 2008 R2 to a 2012 R2 deployment. It's a really good session and something I strongly encourage you to come to. We go really deep on the process there. Today, however, I'm focused on talking about what we've done. Clicker? My clicker's not working. Nope. It started working just as I was about to put it down. Okay. So you've heard us say this a couple of times already today, but 2012 has been just a huge release for Hyper-V. We had a lot of fun working on it, but frankly, we've been surprised by just how happy people have been with it. So that's been great to see. One of the things I would like to call out is I can count on my fingers the number of customers who I believe are getting everything they can out of 2012 today. We have a huge number of features in 2012, and the reality is most people that I talk to today are only using a subset of them. You know, they've decided, okay, we're going to roll out SMB, but we're not going to use replica yet. You know, they've decided, okay, well, we're going to use replica, we're going to use network virtualization, but we're leaving our storage alone. And it's been surprising to me as we've been getting ready to talk about 2012 R2, the number of people have been coming to me and saying, hey, Ben, do you guys have this feature in 2012 R2? And my answer has been, well, yes, because we had that feature in 2012 and we're not in the habit of taking features out. So I would like to encourage, if you're using 2012, do just take the time to go over some of the launch documentation that we released for 2012 where we went over the new features and see if there's anything on that list that pops for you as like, oh, wait a second. Yeah, I forgot they did this functionality and I haven't got around to looking at that. It has been a huge release, but we're not slowing down. 2012 R2 is another big release for us. But the other thing I'd like to mention, this is actually something that I'm really proud of, is, and we announced this about a month ago now, is that right now today, Windows Azure is running on Windows Server 2012. This has been something we've been working towards for a while now. You may or may not have been aware of this. When we started working on Windows Azure, they had their own custom code base, which was, forked from the Windows Server code base. But it's always been our goal to get to the stage where the bits that you deploy in your private cloud were exactly the same as the bits that we deploy in our public cloud. And with Windows Server 2012, we're finally there. We think this is a huge achievement for us. We also think it's really great for customers because whenever I talk to a CEO or a CIO about cloud computing, one of the things that gets hinted at is people are always thinking about, okay, I've chosen public cloud or I've chosen private cloud. Have I chosen the right one? What if my business needs change? What if, something in the environment changes so that now I need to change my cloud computing strategy? Now, with Windows Server 2012 as private cloud, and infrastructure as a service provided by Azure running on 2012, we have an answer where we can say, you know what? No matter what happens, we have a story for you. And here's the lovely diagram. You've probably seen this multiple times today. So I'm not going to go into depth on that. I'm going to focus on what have we done in Hyper-V. This is a really temperamental clicker. Apparently, I have to be on this side of the stage for the clicker to work. So I'm going to be standing over here a lot, I suppose. I'm going to be focusing on what we've done in this release in Hyper-V, and I'm going to be going deep on the features and explaining why we did them and why we think they should be interesting to you. So when we started working on planning for this release, there were a couple of things that came up as areas to look into. And I'm going to step through some of those areas today and kind of step you through why we did these features, what we were thinking. The first area that we looked at was what we tentatively call moving virtualization forward. And the idea here is, with 2012, we felt like we'd finally arrived. We had a really solid platform. We had great features. And people were coming to us and saying, yep, this is great. We're deploying. And one of the questions that we asked ourselves was, okay, we're the virtualization team at Microsoft. If anyone is in the position to change the way we think about virtualization, to do something completely new with virtualization, it is us. So what can we do? And there were a couple of things that came up. The first thing is the Generation 2 virtual machine. This is a new type of virtual machine. So it's based on UEFI, and it brings a new set of functionality. I'm not going to talk much about it on this slide because I prefer to demo it. But this is one of the new investments that we made. The next investment was enhanced virtual machine interaction. This is a really cool feature where we actually get to do something really hard in an easy way because Microsoft is not just a virtualization company. We have a full toolkit available to us. The final thing that I put in this bucket of moving virtualization forward is the automatic activation feature. This one I'm going to talk about because it's kind of hard to demo. With Windows Server 2003 R2, we changed the way that we licensed Windows Server. A lot of people don't realize that we did it all the way back then. But with 2003 R2 was the first version of Windows Server where we said, hey, what we're going to do now is we're going to tie a number of free rights for running Windows Server in a virtual machine to the different SKUs of Windows. Now with 2003 R2, I believe what we originally said was if you're running Standard Edition, we'll give you 1 virtual machine. If you're running Enterprise, we'll give you 4 virtual machines. And if you're running Data Center, we'll give you unlimited virtual machines. So we did that, and an amazing thing happened. Within the next 2 years, our sales of Windows Server Data Center went through the roof. Prior to this, Windows Server Data Center, we sold a couple here or there. When we made the licensing change and people all of a sudden realized, wait, I can put Data Center on the host and I'm done for licensing, it started selling like crazy. And it was fascinating going out and talking to people about this because it was selling like crazy for 2 reasons. The first reason was, in most cases, it was genuinely cheaper. I'm running enough virtual machines that that's the cheapest option. But the second reason was it was easy. One of the biggest challenges that we were hearing from people about virtualization was, I don't know whether I'm in compliance with licensing because I can't keep track of how many virtual machines I have because we're spinning them up all the time. And so Data Center provided a great way for people to go, you know what? I've got Data Center on the host. I don't have to track that anymore. So moving forward, we saw real enthusiasm around this licensing model to the point where with Windows Server 2012, the only difference between the different versions of Windows Server is the virtualization rights. A lot of people have missed this one. So in the past, we had a lot of feature differentiation. That's all gone. So you want to do clustering? You can use Standard Edition. Heck, you can even use the free edition of Hyper-V. They're all the same now. They have the same features, the same functionality. The only difference is the number of virtual machines you're allowed to run. But even with 2012, if you had data center, you had the unlimited virtualization right, you still had to do key management. If you're in an enterprise environment, this is a pain, because you have to have your KMS server, you have to hook up your virtual machines, you have to yada, 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 yada. If you're in a hosted environment, this is a nightmare. Because in a hosted environment, the guy who manages the virtualization infrastructure is different than the guy who manages activation of the guest operating system. Two completely different worlds. So with Windows Server 2012 R2, we have this feature, automatic activation, where you put Windows Server 2012 R2 in a virtual machine, it will reach out to the host operating system and go, hey, are you an activated copy of Data Center? And if it is, it'll go, great, I'm activated as well. And there's nothing for you to do. It's the reason why I don't demo this, because I don't know how I would. I'd bring up a VM and go, look, it's activated. And I didn't do anything. Not really something that you can demo. But some questions that I've got about this. The first one that everyone asked me is like, yeah, there has to be a catch here, right? So this is only for VL licensing or only for whatever. No. It doesn't matter what licensing scheme you're under, whether it's VL, MAK, OEM, whatever other three-letter acronym we have for licensing today. If the host is activated, the guest is activated. Done. Simple. I actually had someone ask me, well, what happens if I build a virtual machine that I'm then going to give to someone else? What happens there? Well, this is actually even better for you. Because if you are in a situation today where you have virtual machines that are going between two different organizations or two different groups, you know that key management is a right pain. Because you give that virtual machine away, it takes your key with it. Well, with automatic activation, the virtual machine doesn't have a key anymore. So if you give that virtual machine away and someone tries to run it on Windows Standard, we're going to come up and say, okay, please give us a key. This virtual machine doesn't have one. But if they try and run it on their activated copy of Data Center, we're going to say, oh, good, we're in a licensed environment, and everything's just going to work. So now that I've talked about that, let me wrestle with my clicker. Let me demonstrate Generation 2 virtual machines and the enhanced VM Connect. Let me see if I can use this switch. Yes, fantastic. So, Generation 2 virtual machines. I have a master demo script for this, so it does all the setting up for me. So, as I mentioned, Generation 2 virtual machines are a new type of virtual machine. At a technical level, this is a virtual machine that's now a UEFI-based virtual machine, not a BIOS virtual machine. But at a more architectural level, the way I like to talk about this is the virtual machines that you've been using to date have been lying to you. In a nice way, but they have been lying to you. Because when we started doing virtualization, back in the late 90s, early 2000s, we were trying to build a virtualization solution for a world that did not know or care about virtualization. I'm not making this up. I can remember being in meetings in 99, 2000, talking to people about this concept that we had for a product called Virtual Server, where I had people go, well, I'm not sure people would actually want to run servers in virtual machines. That conversation happened. So the virtual machines that we built would try very hard to look like physical computers. So here I have a Generation 1 virtual machine, and if you go into Device Manager, what you can actually see is you can see a bunch of stuff in here that exists solely to trick operating systems into thinking that they're running on a physical computer. So this is my favorite one, actually. We have the PCI to ISA bridge. We have our Pentium 2 processor to PCI bridge. We have a bunch of emulated stuff in here that, frankly, you don't want, you don't need, but it's all there to try and make this virtual machine look like a physical computer. So with a Generation 2 virtual machine, what we did was we went, hey, it's not 1999. It is 2013. Virtual machines are not a novel new idea. They are mainstream. Operating systems today aren't fooled and think they're running on a physical computer. They know about virtual machines. They're customized for virtual machines. They're optimized for virtual machines. So let's stop all this lying and pretending, and let's only expose into a virtual machine virtualized infrastructure. So if I come into my Generation 2 virtual machine, what you're going to see here is there's no PCI to ISA bridge, there's no processor bridge. There is VM bus, and there are virtualized devices attached to VM bus, and that is all. So what does this get you? I mean, this is a cool architectural thing. It's something we're really excited because we think we're going to be able to do some amazing stuff on it moving forward. But what does it get you today? Well, it gets you a couple of things. The first thing is it actually greatly simplifies virtual machine management. Let's bring up the settings on my Generation 1 virtual machine. Hopefully, you all are familiar with this. Got a bunch of settings. I can go in, tweak, and configure, and do whatever I want. If I bring up the same settings on a Generation 2 virtual machine, you're immediately going to notice that half the things are missing because they're not there because you don't need them on a Generation 2 virtual machine. So things that you don't need on a Generation 2 virtual machine. You don't need an IDE controller anymore. We can boot off of our virtualized SCSI controller. You don't need legacy network adapters anymore. We can boot off of our virtualized network adapter. So this becomes a lot simpler and a lot easier from a management point of view. It's also great to be able to finally boot off of those devices. There are a couple of other things that you get. So as I mentioned, we're doing this by using UEFI. This means you actually get support for secure boot inside of virtual machines. And what that means is your virtual machines are now protected against rootkits and kernel attacks just like a UEFI-based physical machine would be. Now, one question I always get when I step through Generation 2 virtual machines is, so there's some sort of performance angle to this, right? These are incredibly fast. No. We've done a lot of work making Generation 1 virtual machines incredibly fast, and Generation 2 virtual machines, for the most part, are as fast as Generation 1 virtual machines. There are a couple of areas where they're different. Generation 2 virtual machines boot slightly faster. In our benchmarking, they boot about 15% faster. The operating system installs to them a heck of a lot faster. If you do a side-by-side install in a Generation 1 and Generation 2 virtual machine, you'll see a Generation 2 virtual machine will install about twice as fast as a Generation 1 virtual machine. The next question that I get is, can I run Generation 1 and Generation 2 virtual machines side by side? Of course you can. I've been doing it here in this demo, but I still get people asking that. I'd now like to quickly show you what this looks like when you're creating a virtual machine. So if I create a virtual machine, you're going to see a new virtual machine wizard, largely similar to what you've seen, what you have today. However, now when I get to this page, we have the question, okay, do you want a Generation 1 or a Generation 2 virtual machine? Apart from this, the process is the same. Now, a couple of things to highlight here. We are still defaulting to a Generation 1 virtual machine. Why are we doing that? Well, the first reason is all your virtual machines are Generation 1 virtual machines today. So when you move to 2012 R2, we expect you're probably going to stick with Generation 1 virtual machines for a while. Really encourage you to look at Generation 2 virtual machines, see where it makes sense for you. The second reason is because of all the changes that we've made in Generation 2 virtual machines, because it's a UEFI-based solution, there is a much smaller set of supported guest operating systems. Specifically, the only guest operating systems that you can run in a Generation 2 virtual machine are the 64-bit versions of Windows 8 or 8.1 or Windows Server 2012 or 2012 R2. That's it. We're hoping to expand that list in the future, but right now, that's all the feature, all the supported operating systems. The final thing to say about Generation 2 virtual machines is today, apart from the ability to boot off of SCSI and Virtualized Network Adapter and support for secure boot, there are no features that are unique to Generation 2 virtual machines. I want to say that now because I'm going to demonstrate a lot of other features, and at the end there's always someone who's like, hey Ben, feature X that you showed, is that Generation 2 only? No. All the other features I'm going to show today, they're supported both for Generation 1 and Generation 2 virtual machines. So the next thing I want to show you is the work that we've done for enhancing the experience for VM Connect. So most of you here are using Hyper-V, so you're probably very familiar with the VM Connect UI that we have today. This is the basic screen interface for a Hyper-V virtual machine. And it is very basic. I'll be taking questions at the end. I have a lot to get through. When we originally designed this, it was our goal to just give you the equivalent experience of what you get if you went and sat down at a virtual machine. At a physical computer. It's actually really funny. When we started working on this, and I started working on Virtual PC in 1999, we used to refer to this experience as the glass console mode, because we're like, well, if you went and sat at the screen, you know, the glass console, that's what you get. I had a new hire start 6 months ago, and they're just out of college. And trying to explain to them what I meant when I said the glass console mode was very awkward. It took about 15 minutes for me to get this concept through to them. But we've always modeled this on, like, what would you get if you sat down at the computer? Now, the interesting thing is, when we talk to people about when do you use VM Connect, you know, because we assume most people are, you know, they set up their server and they use remote desktop to connect to it. Well, you use VM Connect when something's gone wrong, was the answer that we got most often. You know, yeah, if everything is fine, I'm going to manage it remotely like any server. But if something's gone wrong and I need to troubleshoot, then I'm going to go and use VM Connect. And the number one complaint we got from people using VM Connect was, boy, does copy and paste suck. No, so, and I'm seeing nods. I saw you say yes. So, for those of you who haven't been initiated into this world, the copy and paste solution that we have in VM Connect in 2012 is, we actually call this the ghost writer. Because what happens is you say paste, and we take any text that is in the host clipboard, and we actually simulate someone typing on the keyboard. And if you paste a large amount of text, you can actually see the characters coming in as they're being typed. Because that's all we had. So that's completely changed. So here I have some text and a graphic, which I would never have been able to copy and paste before. Now I come in here, and it's there. Thank you. And I love that I get applause for that, because honestly, that is the most boring demo I've done in a while. Because I can also copy and paste files in both directions. But while I'm at it, let's just go crazy. And by the way, let me highlight, you'll see I have no network connection for this. So I've just copy and pasted a video into my virtual machine. And what you'll find out in a moment, just be quiet, is that I have video and sound in my virtual machine. This is running on Hyper-V's server. So let me close that. So how did all of that just work? What's going on here? Well, what we've done is we've actually worked with the remote desktop team to deeply integrate remote desktop into Hyper-V and VM Connect. So now, even though I have no network connection to this virtual machine, I'm actually getting a full remote desktop session into the virtual machine. and I'm getting all the functionality that I would get from remote desktop with that. So let's switch back. Now I'm going to go a little deeper on the things I've just shown you. See if my clicker is behaving. Nope. This is a really temperamental clicker. So here, I'm not going to step through all of this. I put this slide in here so that you can grab the slides afterwards. This is a detailed list of all the hardware changes between a Generation 1 and a Generation 2 virtual machine. So as I said, you can look into this afterwards. But I would like to spend some time going through the experience with VM Connect and talking about what's really happening here under the covers. And first, let me step you through what it looks like when you're using VM Connect today on 2012. So I go through, I have an application in my virtual machine. It talks to the video driver inside the virtual machine. The video driver comes over here, and in the parent partition, we essentially create a bitmap. We create a frame buffer of like, hey, here's what was drawn on the screen. Then VM Connect connects, and it gets that bitmap, and it sends keystrokes. That's what it does, and that's the experience that you get. Bitmaps coming out, keystrokes, mouse clicks going in. With the enhanced VM Connect, we've left this mostly the same. The one thing that we have changed is that instead of using a video driver inside the virtual machine, we're now using remote desktop. Apart from this change, the actual flow is exactly the same. But now my VM Connect is getting a remote desktop session. So some key things to point out, and we were very careful about this. The integration with remote desktop works in every scenario where VM Connect works today. So I showed you this working when I didn't have a network connection in the virtual machine. But, and this surprises a lot of people, this will also work if your virtual machine is on a completely different network. It will also work if your virtual machine is actually running on a server core deployment and you're running VM Connect remotely. All those scenarios work, and even in the server core case, I can still do copy and paste. I still get sound. I still get all the cool integration. Now, at this point in time, I usually have someone put on their tinfoil hat and say, I have security concerns about this. I'm not sure I want this in my environment. We understand your concerns. For that reason, we do provide the ability to turn this on or off per your preference. In 2012 R2, we actually have it set up so that by default, when you deploy Hyper-V on a server instance, we do not turn this on. If you deploy Hyper-V on desktop, we turn it on by default because everything's running locally and you want a great experience. But we do provide a control. You can manually turn this on, turn this off as it's appropriate for your environment. So that was some of the innovative stuff that we've done for just moving virtualization forward. The next thing that we did, and hopefully this comes as a surprise to no one here, is we went, okay, 2012 was a great release for private cloud. How do we make 2012 R2 even better? We're going, and I can guarantee you, by the way, let me give you some insight into the future. Let me do some early disclosure for you. I am fairly certain that the next time we release Windows Server, I'm going to be talking about how we've made private cloud even better. I know that's a big revelation, but hopefully not too much of a surprise. So what have we done in R2 specifically for private cloud? The first big one was cross-version live migration. We knew that there was a lot of excitement around 2012, and we knew that people were deploying it, and we did not want 2012 R2 to slow down the success of 2012. So we've done a lot of work to ensure that it is very easy to move virtual machines from 2012 to 2012 R2 with zero downtime. And I'll be showing that in a moment. The next thing that we did was faster live migration. And hopefully you saw the demos of this in the keynote today. This is something that we're really proud of and really excited to have. and I'll be talking more about that after the demo. We also did online VHDX resize. We showed this in the What's New in Windows Server 2012 R2, but this is the ability to both increase and decrease the size of a virtual hard drive while a virtual machine is running. We also added the ability to do live virtual machine export or clone. So you can have a running virtual machine and you can export it while it continues to run. You can have a running virtual machine, you can take a snapshot on that virtual machine and you can export the snapshot while the virtual machine continues to run. In case you haven't got the hint by now, we really care about keeping your virtual machine running. I feel like every time I do these shows, I'm up here talking about the next thing that we've added of like, and now you can do this while the virtual machine is running. So now I have a demo, and I will confess I am going to be using a video for this one demo because I'm supposed to be doing it from this system, which, as you can see, this is supposed to be a remote desktop session into my lab back in Redmond. And right now, this demo would involve a lot of talking because all I'm getting is a black screen because of network connectivity. Luckily, I do have a video of what I was going to show there. So let me bring this up. So if my remote desktop session had worked, you would have seen that I was connecting to my SCVMM server, and I have my Windows Server virtual machine here, and I've just started a live migration. Now, what I'm doing here is I'm doing a live migration just between 2012 and 2012. I'm doing this to provide us a baseline, some baseline numbers for the following live migrations. Now, this demo environment, honestly, is nothing to write home about. So I'm a program manager, and it's a cool job, but one of the things about being a program manager at Microsoft is we don't get much budget for hardware. So most of my demos are actually done on hardware that the test team was about to throw out because they got new shiny hardware. So this whole demo is being done just on single processor Core i7 systems. For the most part, the demo is being done on 4 1 gigabit network adapters. So very standard. I have 4 1 gigabit network adapters. I've configured converged networking and very basic systems. So on the side here, you can see I have 2 clusters set up in SCVMM. I have Boeotia, which is a 2012 cluster, and there my first live migration is finished. You can see live migration took 66 seconds. And what I'm going to do now is I'm going to do a cross-version live migration. So getting back to where I was, I have Boeotia, which is my 2012 cluster with Clio and Calliope, and then I have Mount Helicon, which is a 2012 R2 cluster. So what I'm actually doing right now is not just a cross-version live migration, it is a cross-version, cross-cluster live migration. So the key thing to call out here is, with the work that we did for cross-version live migration, we've essentially enabled cross-version everything. So one of the common questions I get here is like, when you say cross-version, does that include cross-cluster? Yes. Does that include shared nothing? Yes. Any form of live migration that you could do in 2012, you can now do between 2012 and 2012 R2. We also, as a complete side effect, made snapshots and save states cross-version compatible. So now if you're just doing an in-place upgrade, you don't have to worry about getting rid of snapshots before you do the upgrade. So not officially on our plans, but it kind of happened as a result of us doing the cross-version live migration. So this live migration will finish in just a moment, and it will have taken exactly the same time. That's what we expect. So now I'm going to start a third live migration. And this is same virtual machine, exactly the same infrastructure. But now that I'm on 2012 R2, I have compression. And what we'll see is we'll see a sizable improvement in speed. And I have to tell you, for this demo, I actually have a PowerShell script that has put a lot of random data in memory to slow compression down. Because if I do this on an idle VM that's not doing anything, compression is insanely fast. But even with a bunch of data in memory, there, 18 seconds, 66 to 18 seconds, same infrastructure. So the final thing that, final live migration that I'm going to do is I'm going to live migrate this virtual machine back from between the two 2012 R2 servers. But this time I'm going to switch from my 1 gigabit network adapters to an RDMA-enabled network adapter. And this time, we'll see that the live migration is much faster with RDMA. So I'll just wait for this. I'm not going to try and talk through this because it happens quicker than I can fill the space. 8 seconds. So we started at 66 seconds. We're down to 8. So I have this virtual machine over here. And keep in mind, this virtual machine has been running the whole time. Now that I'm on here, there's actually a number of features I can take advantage of without having to update integration components, without having to reboot. So in this demo script, I'm going to show you live expand of the virtual hard disk. Now, we showed this earlier today in the What's New in 2012 R2. That time, I was showing it with the Hyper-V Manager. In this demo here, I'm doing the same thing through System Center Virtual Machine Manager. And there's something I'd like to call out here. I have been working at Microsoft on virtualization for 10 years now. This is the first time I am at TechEd doing a demo in System Center Virtual Machine Manager. There's a reason for that. This is the first time that we're releasing the two products at the same time. And I'm actually really excited about that because I've never been able to use System Center Virtual Machine Manager much before because they've always been behind us by 6 months, so they never supported what I was working on. I've been using Virtual Machine Manager for the last 6 months now. It's been great. I finally get what all you people are talking about when you say it's so useful in your environment. So I'm actually really excited for that. So I just did the live resize, and now I'm going to do a live clone. And this is, once again, this is a feature that you get in Hyper-V Manager. You can do a live export of your virtual machine. In SCVMM, you can do a live clone of your virtual machine. So that's going to go ahead, and the video will finish in a moment. But now that you've seen all these features, and they're cool features, you may be wondering, okay, that was cool. Why do I care? And there are a couple of things I want to step you through to explain why we think these features are so important for us to be doing. This is going to kick off a job, and then the video will finish. So I'll actually switch across. So first, let me talk to you about why faster live migration is so important. Because you saw that demo. I had gigabit networking. I had a 6 gig virtual machine. And we took live migration from 66 seconds down to 18, down to 8. And you may be going, well, you know, Ben, 66 seconds is pretty damn fast. Like, why do I care? You know, I got 2012. I'm happy. So my answer to that is, I did a demo with one virtual machine because I have a very limited amount of time here. The real scenario is you're in your environment, you have an 8-node Hyper-V cluster. Each node has 128 gig of RAM. It's running at about 80% capacity. It's Patch Tuesday. It's time to patch the cluster. Now, that means you're going to have to live migrate every virtual machine in your cluster. Yar. That's how we do it. Now, we have provided some automated tools. We have the SCVMM will automate this for you. We have the cluster-aware updating. And I know that some of you have enough faith in us that you're going to kick that off overnight while you sleep. And God bless you for having that much trust in us. But I know that most of you do not. I know that most of you, this is a process that you are going to babysit. In fact, for most of you, what's going to happen is it's going to be Patch Tuesday. You're going to see that there are some patches for your hosts. The first thing you're going to do is you're going to send out an email, and the sound people are going to hate me, but I love doing this. You're going to send out an email that goes, "Warning, I am about to patch the cluster. Everyone, hands off the cluster. I will let you know when I am done." Come on, we know you do that. And then you kick off the update. Now, if you are running in my configuration, and I know many of you are, where you're using gigabit networking and you have multiple connections, and you have that size deployment, even assuming that you were deploying the world's smallest patch and it took no time to deploy, you are going to take about 10 to 12 hours to ripple those virtual machines around. And it only takes longer the more virtual machines you get. Let me tell you, that is a terrible day for you. Honestly, who wants to spend 12 hours watching a cluster update? So you're going to deploy 2012 R2. Out of the box, you get compression. Now, we've done extensive testing of this. The worst case scenario we've seen is that compression makes things 40% faster. Worst case. In most cases, we've seen that it makes it 2 to 3 times faster. So we just took that 12-hour process and we brought it down to 6. So you don't have to work overtime on that day. Fantastic. But what you really want to be looking at is RDMA. Because I am not exaggerating here. We have seen RDMA go so fast that we were limited by the speed of the memory in the servers that we were live migrating between. And we did that with 3 RDMA adapters. That's it. We wanted to see how fast we could get things to go, and we found that after the 3rd adapter, putting more adapters in didn't make anything faster. And the reason was that we were transferring memory at 16 gigabyte a second, and the physical server memory, the bus, could not keep up with it. So if you go out and invest in RDMA, that 12-hour update will now happen in under an hour. It's now something you can do in your lunch break. So that can change the way you think about how you maintain, how you load balance, how you patch your environment. That's why faster live migration matters. What about the online export? It's a cool feature, yeah, but why does it matter? So let me step you through this one. And this, I know that many of you will have experienced. It's a Thursday afternoon. By the way, bad things happen on Thursday afternoons. Have you ever noticed that? It's just something about Thursday. It's a Thursday afternoon. You think everything's okay. You get a request to go in and make a trivial configuration change on a SQL server. You log into the SQL server, and you go to open up the management tools, and they crash with the strangest error message you've ever seen. And now you have a problem. Because the problem is, on one hand, something is clearly wrong here. This tool shouldn't have crashed. On the other hand, the SQL server does appear to be running, and it is serving its function. What do you do? The reality is you have 2 bad choices. Choice number 1, you go, well, the SQL server is running. I'm just going to walk away and leave it. Hands off, like everything's good. Because I got to tell you, when that server crashes in 2 hours' time, you better not say, oh yeah, I logged into that 2 hours ago and things seemed kind of screwy, but I just walked away. No, that's not good. So that's bad choice number 1. Bad choice number 2 is you go, well, something's wrong here. I'm going to take this server down and have a look at it. Because you better hope that you find a problem if you do that. You do not want to take a SQL server offline for 2 hours, have people scream at you for 2 hours, only to come away going, I have no idea, and I've rebooted it, and it seems fine now. It was just a passing thing. No, you don't want to be there either. So now you can take that virtual machine and you can say, I'm going to keep it running. I'm going to clone this. I'm going to go put it on another server, bring it up, disconnect it from the network, do my triage, do my investigation, understand what's happening, and make the right decision. I know that I'm making the right decision without having to affect my running system. So let's go a bit deeper on these features. The cross-version compatibility. As I mentioned, when we did this, we enabled it for all live migration, but we also enabled it for all other features too. One of my favorite scenarios that we enabled here is actually if you're doing an in-place upgrade of Hyper-V on the desktop. Because if you have Hyper-V on Windows 8 and you do an in-place upgrade, we don't bother telling you that there are virtual machines running or that you've got snapshots or so on. We just automatically put them into a safe state. We update your operating system. We come up and we start your virtual machines back up automatically. It's fantastic. It's amazing. You have a bunch of virtual machines running. You update the host. You get to the end. You log into Windows 8.1, and all your virtual machines are still running like nothing happened. All your snapshots / checkpoints are good. Life's great. This is also true for import-export. Basically, anything that you can do to move a virtual machine, it now works cross-version. Next thing I want to talk about is go deep on is the compression. If you've thought through what we're doing here, one of the things that you'll have immediately realized is, okay, you guys are compressing the memory in order to send it. Compression takes CPU resource. Like, how does this affect the performance of my box? The first thing I want to say is most people are still woefully underutilizing their CPUs. Honestly, it's amazing. We have the Scrim data on this. I talk to customers about this. Even after people virtualize, we see that most physical CPUs out there are in the 10 to 20% utilization, sometimes getting up to 50. So for the vast majority of servers, trust me, you've got CPU capacity to spare. But even if you haven't, we were very careful about this. We actually actively monitor the entire load on a Hyper-V server while we're doing a live migration. We monitor the CPU usage of all the virtual machines, of the hypervisor, and of the parent partition. And we dynamically adjust how much compression we're doing in reaction to what's happening in the workload. So if you were in a situation where you had a physical computer that was flat out using all of its CPU just running virtual machines, and you did a live migration, yeah, we wouldn't use compression. We would detect that and we would back off. But in all the workload testing we've done, there's almost always CPU cycles available, but we are very careful to make sure we don't affect the performance of the workload running inside the virtual machines. Next thing I want to go deep on is the RDMA. So when we decided to do a live migration over RDMA, we actually looked at a number of different ways to do this. And the way we ended up doing it was not obvious to us at the outset, but it's given us a number of benefits as a result. What we're actually doing is we're doing live migration over SMB rather than over TCP, which is what we do in 2012. When we do live migration over SMB, it means that one, if you have the RDMA infrastructure, we take advantage of it because SMB has SMB Direct. But two, it also means that regardless of whether you have RDMA infrastructure or not, we now get support for multi-channel. So we can take advantage of multiple connections in order to speed up your live migration. So with all this in mind, we have some fairly simple guidance, because in 2012 R2, compression or RDMA is an either-or choice. You can't do both at the same time. We default to having compression enabled. We know that compression will always make things better. Worst case scenario, it only makes it a little bit better. But our general rule of thumb that we're going to be giving people is, how much bandwidth do you have for live migration? If your live migration bandwidth is 10 gigabit or less, then use compression. All the testing that we've done has said that we'll get things faster. If you have greater than 10 gigabit available for live migration, then use SMB direct. So a couple of key things to point out here. If you have two 10 gigabit links and it's not RDMA enabled, use SMB. It will be faster. That's what our testing has shown. It's kind of hard to find, but it is out there. If you have 1 gigabit RDMA enabled hardware, it's not worth it. Don't use it. Use compression. So that's really the decision point about whether you go with compression or RDMA is all about how much bandwidth do you have available for live migration. So what else have we done for supporting private cloud? Well, the next thing that we've done is we've really doubled down on support for Linux guest operating systems. We've added a number of new features. We've added full support for dynamic memory. We've added support for online backup. We've added support for online resize. We've also implemented a new video driver. I'll be demonstrating all of that in a moment. We added storage QoS controls. So I can now control how much bandwidth a virtual machine gets access to. We've also added support for guest clustering. We talked about this in the What's New in 2012 R2, and this is guest clustering with VHDX. No need for iSCSI. So let me switch across to my laptop and step you through what some of this looks like. So first I want to show you some of the Linux improvements. And I'm going to start by showing a very simple demo that I've got to do at TechEd US. I got in trouble with the Linux guys for forgetting to demonstrate this, so I'm going to start with this one here so they don't yell at me this time. And this is, I'm going to demonstrate and show you that one of the new things that we've developed is we've developed a Hyper-V video driver for Linux. Unfortunately, and you're going to see this a couple of times in my demo, there is a bug in it which causes me to get this bar here. It happens whenever I restore a snapshot. It goes away, but there you go. So here I have a CentOS virtual machine with all the integration components. Now, in a Linux distribution today, what we actually have is we have a Hyper-V mouse driver, so the mouse doesn't get captured, but we don't have a video driver. The result of this is that you can actually see I have a little dot that the mouse follows around. And that's because we have this disconnect. We're still using an old video driver. Now, interesting piece of trivia. This little dot and mouse has a very specific term on the Hyper-V team. You get this experience whenever we have the mouse working in virtualized mode, but the video working in old-style mode. And because we have a dot that the mouse follows, we call this cheese and mouse mode, because the mouse follows the cheese around the screen. So if you're ever talking to a Hyper-V dev and you hear the phrase cheese and mouse, this is what we're talking about. If I go across to my SUSE virtual machine, no cheese and mouse. The mouse just works. Not the sexiest demo in the world, but it took a lot of work in order to get that. So the next thing I want to demonstrate is the dynamic memory support. I showed this in the overview session, but in case you weren't there, I would like to just quickly show it again. If I bring up the stats on this virtual machine, the first thing you're going to see is that I actually booted this virtual machine with 1 gig of memory, and we've brought it down to 700 meg. So that's using the memory ballooning technology. And frankly, that's not hard to do. The hard thing to do is the dynamic add. And we worked very closely with the Linux guys to get full support for dynamic add. So what you're going to see is that as this script runs, I'm able to allocate memory to this virtual machine, and my server is going to pull it away. Only I should have stopped to this guy, because my box is out of memory. So the fun thing is, because my server is running low on memory, what you should actually see as I'm doing this is if you watch the memory figures on the other virtual machines, you should see them go down as we remove memory in order to add it to this virtual machine. So there, we just had a bunch of memory come out of the other virtual machines. And when I free, we should see the memory go back. So there, memory just went down, got redistributed. So the key thing here is, not only have we done dynamic memory for Linux, we've done dynamic memory in exactly the same way as we did it for Windows. You get all the functionality that you get on Windows with dynamic memory now on Linux. So the final thing I want to demonstrate is the support for backup on Linux. So let me just fire this up. People don't like to talk about backup a lot. You know, it's not sexy or exciting, but the reality is it's something that we all need and rely upon. I have virtual machines starting up. So with Windows Server 2012, if I tried to back up a Linux virtual machine, we would actually put the virtual machine into a safe state in order to take the backup. That's a terrible story. With 2012 R2, we have done support now that we can back up a virtual machine live while it is running. So if I come in here, I can find my virtual machine. You can see it's going to be an online backup. Let me bring this up. Resize a little. So this is going to start. And what's actually happening here now, a key thing to understand is on Windows we have the VSS infrastructure, which allows us to do snapshot-based backup with zero downtime. Linux doesn't have that infrastructure. But what I am doing here is I am taking a VSS-based backup in the parent partition. We're using the VSS infrastructure in Windows. We've then developed a Linux integration component where when it's time to take the snapshot, we issue a file system freeze inside the Linux virtual machine. It continues to run, but we get a file system consistent point-in-time image of the virtual machine. That's actually already happened. We're now copying off the image that we made. So, question I like to ask at this point in time. First, a show of hands. How many people here have Linux in their environment? Okay, I would say about half the room. For everyone here who just raised their hand, how many of you have a backup strategy for your Linux servers? That is a lot fewer hands. Let me just point out something. For all the people who didn't raise their hands just now, bad people, please back up your servers. Of the people who raised their hands saying that they have a backup strategy for Linux, raise your hands if you have a backup strategy for Linux that is not a shell script that copies files once a night. Okay, that was more than TechEd US. I'd say we had about 20 people. So we now have a fantastic story for backing up Linux. So I'm showing this here with Windows Server Backup. This also works with DPM. You get Linux inside of a Hyper-V virtual machine. You're now able to do zero downtime backup, file system consistent. It's a great story. If you're not backing up your Linux servers today, I would suggest stick them in Hyper-V virtual machines. Take advantage of this. It's a very simple and easy way to back them up. Yeah. I have to find my mouse. So while that is running, I'm going to get impatient and kick off my next demo. So next thing I want to demonstrate is the support that we have for storage I/O control. So today, Windows Server 2012, we do have QoS for CPU. We have QoS for memory through dynamic memory. We have QoS for networking. We don't have QoS for storage. So if I bring up a virtual machine here, I'm going to start a very heavy I/O workload on it. Now, running 2012, there's very little that you can do to mitigate how this affects other virtual machines on the system. So here you can see I've now run a heavy workload. I'm getting about 10,000 IOPS out of it. Now, at this stage, every other virtual machine that I have running on the storage now has slower storage performance because of this. This is annoying in my configuration. This is a real problem in a hosted environment. In a hosted environment, people don't know how what they're doing in one virtual machine is affecting other virtual machines. So, very simple demo with Windows Server 2012 R2. I can now come in here, enable QoS, and restrict this, let's say, to 300 IOPS. And pretty much immediately, workload is now restricted. Key thing is, there's no downtime, there's no disruption. So for the person who's running the workload inside the virtual machine, the only thing I see is it takes a bit longer to complete now. But my virtual machine is no longer negatively affecting other systems that are running around it. Let's see, my backup has completed. The second thing I'd like to show around the storage control is not only have we provided the ability to control storage I/O, we've also provided the ability to completely measure storage I/O. So some of you may be aware of this. I suspect most of you are not. In Windows Server 2012 Hyper-V, we built a full metrics infrastructure that allows you to measure utilization of virtual machines for purposes of chargeback. In 2012 R2, we've added the I/O controls. We've also added chargeback for IOPS. So here you can see I've just pulled a metrics report on this virtual machine. I've just pulled it out of a snapshot, so it's telling me pretty much nothing has happened. If I run my workload, wait for it to start up. No, I'm not going to drink a beer on stage. So if I start this workload now, let it run for a little bit, I can pull the updated metrics, and you'll see, okay, I now have new data showing me how much data has been read, written, what the average IOPS has been, and what the average latency has been. This is really handy for two reasons. First, it allows you to do chargeback on IOPS. So you can identify who's using the IOPS and make sure that they're the people who are actually paying for the expensive storage. The second thing is, this can really help you with troubleshooting. The key thing to watch for the troubleshooting is the average latency. You can track this now on virtual machines, and when you get someone who's like, hey, the performance of my virtual machine isn't great, you can pull up this data and you can see, oh, something's going on with storage. We're seeing a very high latency here. And you can understand what's happening there more completely. So I am going to run out of time if I do all my demos. So I am not going to demo shared VHDX. It was demoed in the What's New in 2012 R2. And we also have a separate session on it. So I'm going to skip over that demo now. And the final thing I'm going to talk about is disaster recovery. Flaky clicker. So in 2012, we introduced Hyper-V Replica. Great feature, warmly received. However, as happens when you have a feature that is warmly received, we had a lot of feature requests. So we had to go through and we had to prioritize all those requests. And in the end, we ended up implementing 2 improvements to Hyper-V Replica. I'm going to quickly show them to you. I'm going to explain how they work and what some of the limitations are for you to be aware of. So let me kick off that demo. Wait for that virtual machine to start. So in Hyper-V Replica in Windows Server 2012, we provided cheap, simple replica in box. People really like that. The first piece of feedback that we got, though, was I want more control over how frequently you send replications. So in 2012, we send replicas every 5 minutes. That's non-negotiable. So in 2012 R2, we now give you some control over that. Let me just jump through and get to the page to talk about. So here we provide the options 30 seconds, 5 minutes, 15 minutes. So why these options and why would you use them? Well, the 30-second option was because we got people who came to us and said, okay, I understand that you designed Replica as a great disaster recovery solution for small businesses. That is what we targeted in 2012. Now, I understand that you designed Replica so it could run over a broadband connection. Yep. However, I want to do Replica from one side of my data center to the other. And I have Ethernet. And 5 minutes is a long time. Okay. So we now, for people who are doing Replica either over Ethernet or in a metropolitan area where they have gigabit connectivity, you can now send replicas every 30 seconds. On the other end of the scale, we had people go, you know, Replica's great. However, what I really need is I need a solution that's going to work over a satellite link. And the link comes and goes. And I need Replica to be able to tolerate huge outages. And that's where we provide the 15-minute option. Now, with the 15-minute option, not only will we only try and send replicas every 15 minutes, it also means that we can tolerate up to a 3-hour outage before we put the replica in a failed state. So I'm going to select 5 minutes. No, I'm not. 5 minutes. And go ahead. Now, one thing that I will say, because I know I'm going to get this question at the end, every time I show 30 seconds, 5 minutes, 15 minutes, the first question I get is, but I want to do replica every 47.5 seconds because I've figured that that's the best frequency for my environment. Yes, we understand that everyone wants more fine-grained control here, but my answer to that is we only had a year. And in a year, we felt that we could get good testing on 3 options. We weren't comfortable going with a completely granular set of options. The next thing that we did was extended replication. So now I can go to my replica virtual machine, and I can replicate it to a third location. This was easily our #1 request for replica. And this request came up for 2 reasons. And I'm just going to jump through and finish that off. It's going to send the replica. The first reason that it came for was from hosters. And this was a fascinating conversation and experience for us. Because we designed Hyper-V Replica with hosters in mind, and yet we got it wrong. Whoops. One of the models that we had in mind with Hyper-V Replica was we really want hosters to offer Replica as a service to local small businesses. We're like, this will be great. You know, if a small business doesn't have multiple sites, can't do disaster recovery today, we'll get hosters to do this, and it'll be a good model for hosters, it'll be a good model for small businesses, it'll be win-win. When we got round to actually releasing 2012 and we went out to hosters to talk about this, their response surprised us. Because their response was, yeah, Microsoft, we get your message and that's a great idea. And that's really cool and really exciting and so on. However, we're more interested in using Replica ourselves than we are about offering this to customers. And what we found out was hosters were saying, look, I have multiple data centers myself. I want to use Replica to protect my hosted virtual machines so that I can provide better SLAs at a cheaper price for my hosted virtual machines. And I actually want to do that before I offer Replica as a service. It was a complete surprise to us. So we went, okay. And we have a number of hosters who are doing this today. So that's where we built extended replication, so that now those hosters can have a small business replicate to them, and they can continue to use Replica internally. The second scenario that came up was when we started talking to the medium and the enterprise businesses, where they said, well, Microsoft, you've now given me a tough decision, because I do have multiple sites, and I want to use Replica internally to give me multiple site protection, but I also have a relationship with a service provider, and I would love to do Replica offloaded to them. But I have to choose one or the other, and I don't want to. Well, now with Hyper-V Replica, they don't need to. They can do replication internally and then do it externally. So this is all about enabling those sorts of scenarios. Now, common questions that come up here. First one, let me be really clear. The only configuration we support here is A, then B, then C. We do not support A to B and A to C. We do not support A, B, C, D, E. We certainly do not support A, B, C, D, E, F, A. Though that would be hilarious if we did, but we do not. The supported configuration is A to B to C. The next question that comes up, and this one is important, is we don't require that you use the same method of authentication between A and B as between B and C. What do I mean here? Well, you can use a certificate between A and B, customer to hoster, and then the hoster can use Kerberos between B and C. You can use Kerberos between A and B, an enterprise doing replication internally, and then use a certificate between B and C, going up to a hoster. Those are supported configurations. So, with that in mind, I've gone through all the features. Actually, I skipped over two because I have 3 minutes left. And as has been demonstrated, there is beer being handed out. What are some of the key takeaways here? The first one is private cloud is just getting better. Hopefully that should come as no surprise to you. If you are happy with 2012 private cloud today, I can tell you you're going to be even happier with 2012 R2. And we're doing everything we can to help you get there easily. The next one, increasing virtual machine uptime is always a priority. As I said, I feel like it's been the 4th year now when I've been on this stage and talked about cool things that you can now do while the virtual machine's running. I can pretty much guarantee that next time we do a release, I will be here on stage talking about cool new things you can do while the virtual machine's running. We're always listening to customers. So please, come talk to us. Give us the feedback. I was just chatting to some Microsoft people the other day where they were talking about release cycles and schedules and so on. And one of the points I had to make is, look, there is never a bad time to get feedback. So if there's something you don't like about Hyper-V, come and find me this week and have a chat. And the final point is, we're having fun innovating. We've got some new stuff here, and I'm actually really excited about the future. Because I got to tell you, I'm excited about what we're doing in 2012. I'm excited about 2012 R2, and I am sure I'm going to be excited about what's coming after that as well. So keep on looking for new things that you can do with virtualization and ways that you should be changing your infrastructure and the way you do business because of new technologies, like live migration over RDMA, like all the cool stuff that's happening in storage. There is a lot of value that you can get out of that. So with that, I have a bunch of slides that I'm supposed to show, but they're all terribly boring, so I'm not going to. And I'm going to go to question and answer. I officially have 1 minute left, so I do not mind if people leave. I would ask that you all fill out evaluations. There is a man here with a dashing jacket who I am hoping to beat this year. And that will only happen if you fill out positive evaluations, or you could go to his session and fill out negative evaluations. Not that I would encourage that. But please do take time to feed out evaluations. Also put in detailed feedback. Not many people know this. We can actually, every speaker can see all the detailed feedback, and we have good fun teasing each other about it. So if you like something, if you didn't like something, write it down. We do all read it, and we do tease each other a lot. So questions?
Using the same RGB port, or you use the VM Connect port?
So the question is, with the enhanced VM Connect mode, are we using the same RDP port or are we using a different port? We are not using TCP. There are no ports. We are running, yes, I see you furrowing your brow. We are running remote desktop directly over VM bus without a network. So this is now completely separate. There's no port configuration. There's no firewall. There is no port configuration. No port configuration. Full stop. So, and follow-up question, if RDP is broken, it will still work? Yes. It always works. It works in any situation where VM Connect works today.
Are there any changes in the NVGRE packet in R2?
So the question is, are there any changes in the NVGRE packet in R2? The answer I'm going to give you is there's a session tomorrow on network virtualization and what's new. And you want to ask the speaker there. I can give a very lightweight answer there, and they can give a far better answer. So the question is, there's actually a couple of parts, so let me dig into this. The question was about automatic activation. I want to be really clear. For the automatic activation feature, it is only supported for Windows Server 2012 R2 as a host and as a guest. Now, a couple of key things to call out here. It is only support for Windows Server as a guest because we only do the licensing for Windows Server. A lot of people forget this. There is no version of Windows Server which gives you free licenses for running Windows Desktop in a virtual machine. If you think there is, then I hate to tell you, you're a pirate. Please go out and talk to your licensing people and get that sorted. We only do the licenses for server. The second part of the question, though, was, is it possible to get that for older versions of Windows Server? Anything is technically possible. Is it likely to happen? Not likely. There was a lot of work that had to go in order to make sure that happened in a secure and reliable fashion. So the question is, will you be adding hot add network cards? My question to you is, why do you need it?
Because we always forget to add it all the time. Then the machine has to go down.
What do you need to add a network adapter?
Changing situations in the network, basic configuration changes.
So the challenge that I have here is, if you're using converged networks and network virtualization, which is what we want you to be using, then you should never need to add a network adapter, because we can push huge amounts of data through a single network adapter. We're not limited, by any infrastructure. We can saturate whatever network you have with a single network adapter. If you're using teaming and converged networking and network virtualization, which really you should be, then you can adapt to any situation. Don't get me wrong, I would love us to do hot add of network adapter, and no, we don't have hot add of network adapter in this release. The nerd side of me would love to have it. The business side of me, really? So the question yelled from the back of the room, what about hot add of CPU? Once again, you really shouldn't need it. So this is actually, I've been combating this for a while. If you come from the VMware world, you're probably sizing your virtual machines wrong. So let me go into a bit more nuance on this answer. Yeah, I know we're over time. We are over time. If you want to leave, that's fine. I'm going to continue answering questions until she cuts the power. If you come from the VMware world, VMware does gang scheduling of virtual CPU, and the result of their gang scheduler is that it is costly to have a virtual CPU associated with a virtual machine that you're not using. And so VMware gives very explicit guidance where they tell you, please only add as many CPUs as you think you're going to need. Please, 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 please. And then if down the track your workload changes, you're in trouble. Hyper-V does not do gang scheduling. Hyper-V does free scheduling of VPs. We modified Windows so that it's cool with that. So the result is that in Hyper-V, having extra VPs assigned to a virtual machine has somewhere around a 2% performance impact, if that, has no impact on scheduling at all. So the reality is with Hyper-V, what you should be doing is when you create your virtual machines, create them with a liberal number of processors. I mean, that's what I do. I can't remember the last time I created a single processor virtual machine, because every virtual machine I create is at least dual processor. So, yeah, and I do get it is a valid request to ask for hot add CPU. I'm not denying that. I am saying that I did want to jump on. I know there are a lot of people who follow the VMware guidance for Hyper-V, and it's a bad thing. I hope we do hot add of CPU someday. Oh, good question. I forgot to mention that. Too many new features. So the question was, do you have any plans to add USB support to a virtual machine? And the answer is we kind of have by accident. Because when we did the whole remote desktop integration, USB works there as well.
So I can plug, let's say, USB modem inside my host.
Yeah, because remote desktop now has full USB redirection. There is a group policy you have to enable on the client in order to get it to work. But yeah, that works. I always forget to mention that. Too many new features. This is the last question I'm going to take. I'm going to head over to the expo where they're giving away free alcohol. So the question is, will the improvements to live migration be applicable to live storage migration anytime in the future? The first answer to that is, I don't talk about futures because they would fire me if I did, and I like my job. The second part of that answer is, well, if you're talking about a shared nothing live migration, shared nothing live migration already takes advantage of RDMA because it's built on top of SMB. So if you have an RDMA-enabled environment, and you're running 2012 R2, and you do a shared nothing live migration, you'll actually get full RDMA offload for the entire live migration. Compression, no. But that's not today, but I don't talk about the future, because I'm not allowed to. So I'll be over at the expo hall. Feel free to hunt me down and ask other questions.